the lessons. Okay, so this first one, lesson 4, is pretty much what we already know. If we subbed a value of x in, that came from our divisor, into the polynomial, do you guys remember what we had? So for example, if we were to divide x cubed minus 2x squared minus 4 by x plus 1, what would the value of x be if we set that divisor equal to 0? So if x equals -1 and we sub that into the polynomial, do you guys remember what we would get? What? The remainder. And that's actually the remainder theorem. So we're just going to actually skip this review because we've got a lot to get through. What the review is telling us is we can use synthetic division, or we can use what we're alluding to, the remainder theorem, to get the same result. So let's just go right to the theorem, and we'll do a little practice. Okay, so there's a proof behind this, why we get the remainder. You ready? Where's that? Okay, there's a proof of why we get the remainder, so let's just read through it. We have a polynomial p of x. It's divided by a binomial, x minus a. The remainder obtained is equal to the value of the polynomial when x is equal to a, and therefore we get the remainder of p when x is replaced with a. So going into the algorithm, polynomial is equal to your divisor times your quotient plus your remainder. We can replace the divisor with what we're dividing by, x minus a. Okay, so the divisor was just replaced with x minus a. Now what did we say the value of x would be if we wanted to set this equal to 0? It would be the value of whatever that number is in the opposite sign. So it's going to be a. So all they're doing is taking that x and going to replace it with a. Hence p of a gives you a minus a. What's a minus a? 0. What's 0 times anything? 0. So we're just left with our remainder. So that's a little proof behind the remainder theorem. And why when you sub in the value of the divisor, when the divisor is set to 0, you will get the remainder. So let's practice. Okay, we're going to use the remainder theorem to find the remainder when p of x is equal to this given polynomial. So if we are dividing by x plus 1, what would the value of x be when the divisor is equal to 0? You guys got it. -1. So we're going to solve for p at -1. So looking at the original polynomial, every x is replaced with a -1. And after we do a little bit of calculating, a bit of math, can you guys help me out and tell me what you get as your remainder? What do we get? -12? Okay, very good. So this is our remainder. We can say that p of -1 is equal to -12, which is our remainder. Okay, -12 is our remainder when we're dividing by x plus 1. What would I sub into the polynomial given 2x minus 1? Half. Good. So we're going to solve for p of a half. Replacing all the x values with a half, or 0.5, your choice. And as an exact answer, can you guys please provide the fraction you get after you evaluate? Okay, correct answer is 39/4. which when p, our polynomial is subbed in with a half for x, we get a remainder of 39 over 4, or 9.75. Is everyone okay with that? I'm jumping ahead a little bit, but what happens when the value that you come up with is 0? It divides evenly. Good. And when something divides evenly, we have a factor. That's what we're going to get into a little bit later, but you guys are already ahead of the game. Okay, sometimes you're going to run into questions where they ask you for an unknown. And there's two different ways that you can solve for those unknowns. Okay, one is using synthetic division. The other way is using the remainder theorem. So since we're on a roll with the remainder theorem, let's start with that. Okay, so we have to find the value of a, given that the remainder is 131, when p of x, or polynomial, is equal to 2x to the power of 4, minus x cubed, minus 8x plus 8, and we're dividing by x minus 3. So if we're dividing by x minus 3, what value will we sub into the polynomial? 3. Positive 3. Good. Okay, so we're evaluating p at 3. What did they tell us the remainder was for p at 3? Good. They're telling us the remainder was 131. So 131 is equal to the polynomial at 3. And all we have to do is set that remainder equal to the polynomial when we actually sub in 3 for all the x's. So 2 times 3 to the power of 4 minus 3 to the power of 3 minus a times 3 plus 8 will give us a remainder of 131. We have this unknown a that we need to solve for. So we just need to evaluate a few numbers and isolate the a. So I'll give you a moment to do that. What do you guys get? So I'll let you subtract and add a few numbers, divide by -3, and I'm getting, you're close. It's positive 4.
Oh, really?
Yeah. Did you divide by -3?
No, I had -12 on top. Yeah, but you divide by -3. Oh, that's, yeah.
Yeah, so you had -12 divided by -3, you got a positive 4.
Yeah.
Good.
We should retire away those negatives.
So we have to subtract the 162 over, add the 27 over, subtract the 8 over. You should get -12, and divide -12 by -3, and you get positive 4. Okay, so that's using the remainder theorem. I'm just going to refresh your memory on synthetic division from yesterday. So if we are dividing by x minus 3, the number we put on the side is positive 3. And we put in the coefficients from the polynomial in the top row. So we get 2, -1, -a, positive 8. What other piece of information could I put in right away?
We need a 0.
Oh, you're right. X to the power of 4, x cubed, missing that x squared. So we have to put a placeholder. Okay, I'm glad some of you remember that from yesterday. Good job. Okay, there's another piece of information that we need to include. The remainder is already given, so we can plug that in right away as well. Okay, so first we bring down the first coefficient, 2. we're gonna multiply by the number that replaces x. So 2 times 3 is 6, put that in the next column, bottom row. Okay, add those two numbers together, we get -1 plus 6 is +5. 5 times 3 is 15. 0 plus 15 is 15. 15 times 3 is 45. And when we add those together, we get -a plus 45. And I apologize for my miniature writing there. Next up, we take this and we multiply it by 3. So we get 3 times -a plus 45 plus 8 gives us 131. So how are we going to solve for a? Well, we're just going to use the information we know and create an equation. We have 8 plus 3 times -a plus 45 equals our remainder 131. And then we just solve. So we subtract 8 on both sides and we get 3 times -a plus 45 equals 123. What's 123 divided by 3? 41. And we get -a plus 45 equals 41. Subtract 45 to the other side. And we get -4, divide both sides by negative, and again, a is equal to 4. Okay, we needed the same answer as how we did it with the remainder theorem, and we got it. So, although both methods work, in this one we had to go through the whole process of synthetic division to solve an equation. Using the remainder theorem, we just solved an equation. So I personally think it's just a little bit easier. Okay, now I'm going to teach you guys another strategy when you have to solve for two unknown variables. So in this question, they're giving us two hints. They're telling us find the coefficients, D and C, from the polynomial given. If the remainder is -41 when we're dividing by x plus 3, and the remainder is 74 when we're dividing by x minus 2. So there's going to be three parts to this question. We're going to use the first hint when we have a remainder of -41, come up with an equation, and we're going to simplify it. And then we're going to use the second hint where our remainder is 74, come up with an equation. Both equations from part 1 and 2 will have two unknown variables. When we have two equations with two unknown variables, do you guys remember from grade 10 a technique? Substitution or elimination. We're solving the system. So that's what we're going to do. So first let's use the hint that the remainder is -41 when we're dividing by x plus 3. So if we're dividing by x plus 3, what are we subbing into the polynomial? -3. So right off the bat, we can make a statement that -41 is equal to the polynomial evaluated at -3. And make sure you give yourself some space. We'll need three parts to this question. Okay, so we're going to sub -3 into all the x's of the polynomial. Then just evaluate, we get 162 minus 27D minus 9C minus 15 minus 8. So I've left the D and the C on the right hand side, and if you guys could just help me out, move the 162, the negative 15, and the 8 over. And what do you get on the left-hand side?
Negative 180.
Negative 180?
Yeah.
Thank you. Okay, so can we simplify that equation any further? Is there a common factor in the 180, the 27, and the 9? Maybe 9? Maybe, yeah. So if we go 180 divided by 9, we get, actually let's divide by negative 9. Okay, we get 20. Negative 27 divided by negative 9 is 3. And negative 9 divided by negative 9 is 1. So we have our first equation. And we're just going to put on the shelf for a little bit.
You pulled the 9 out. Where's the 9 go then?
I just divided everything by negative 9. And if you divide by negative 9 on one side,
Yeah.
then it's equalized if you do it on the opposite side.
Oh, so you don't have to do anything with the 9 you pulled out?
No. I'll just show you down here. If I had 180, if I divide by negative 9 on one side, I divide also by negative 9 on the other side.
Yeah, I just didn't know if you had to keep the 9 somewhere.
No.
Okay.
Okay, so we've used our first hint when the remainder is negative 41. There's a second hint when the remainder is 74 and we're dividing by x minus 2. So when that's the case, we can say that, using the remainder theorem, 74 is equal to p of positive 2. So 74 will equal the polynomial where x is replaced with positive 2. So we have 2 times 2 to the power of 4 plus d times 2 to the power of 3 minus c times 2 to the power of 2 plus 5 times 2 minus 8. So then we get 74 equals 32 plus 8d minus 4c plus 10 minus 8. Okay, 10 minus 2, 10 minus 8 is 2. 2 plus 32 is 4. Subtract 34 to the other side, we get positive 40 equals 8d minus 4c. What's a common factor in 48 and 4? 4, so divide everything by 4 and we get 10 equals 2d minus c. And we have 2 equations, still 2 unknowns. Our goal is to solve for d and c. So the third step is to solve the system. Now, some of you mentioned substitution, some of you mentioned elimination. I personally like elimination, especially if the variables line up. So let's stack the equations. We have 20 equals 3d plus c, and 10 equals 2d minus c. When we have a variable where the coefficients are the same but the opposite sign, do you add or subtract to eliminate?
Minus.
So if I minused, I would get 1 minus minus, which would be a plus. So I've got to add. Okay, make sure you add that. 20 plus 10 is 30. And that will equal 3d plus 2d is 5d. Positive c minus c, those cancel out. And from there we get 30 equals 5d. Divide both sides by 5. D equals 6. And to solve for the variable c, you're just going to take that 6 and sub it into one of the other equations. So I'll just use 10 equals 2d minus c. And I'm replacing the d with the 6 that we just solved for. So I get 12 minus 10 is 2, c equals 2, d equals 6. Okay, so that's just another example of how you can use the remainder theorem if you're solving for unknowns. Now moving on to the factor theorem. I think you guys already got it. If you have a remainder of 0, then the divisor is considered a factor. So I'll just read through the actual theorem definition. The binomial x minus a is a factor of the polynomial function p of x if and only if p at a is equal to 0. So if the remainder is 0, then we know that x minus a is a factor. Okay, and then also that's concluding that a, so whatever value is in the divisor, is a 0, or an x-intercept, or a root. Those are the three term definitions we use for 0. So, for example 4, we could use synthetic division, or we could use the factor theorem, which is pretty much the remainder theorem, to prove that x minus 4 is a factor. So let's just use both techniques, just to show you could do it either way. So we're going to set up synthetic division, recording the coefficients of the polynomial x squared plus 2x minus 24. So 1x squared, 2x, and negative 24. And if we're dividing by x minus 4, we put a positive 4 on the side. So let's go through it. Bring the 1 down, multiply by 4. 2 plus 4 is 6. 6 times 4 is 24. Negative 24 plus 24 is 0. So, remainder of 0. And these 3 dots just means therefore, x minus 4 is a factor, and x equals 4 is a 0. Just remember, zeros mean x-intercepts too. So if we went back to grade 11 for a second, and we just factored this to figure out what were the x-intercepts. We started with x squared plus 2x minus 24. If we factor that, what do we get? X plus 6 and x minus 4. So our roots, or our zeros, or our x-intercepts are at 4 and negative 6. So we would say that if we were to divide by x minus 4, that's a factor. If we were to divide by x plus 6, that's also a factor. Okay, and the zeros are 4 and negative 6. This is basically an introduction question, taking you from grade 11 to what we're going to see later with cubic or quartic polynomials. So how about we prove the same thing using the factor theorem, which is essentially the remainder theorem. We can sub the value of our 0, our potential 0, into the polynomial. So P of 4, what will we get? Okay, 16 plus 8 is 24, minus 24, we get 0 again. It doesn't really matter whether you use the factor theorem or whether you use synthetic division. you'll be able to figure out the remainder. Okay, sometimes it's just more efficient to use the factor theorem if all they're asking about is if it's a factor or not. The one nice thing about synthetic division though is it also tells you your quotient, x plus 6. We could have done that by factoring this one too. Okay, so next one, in cases where you're given the remainder is 0, you might have to figure out what the factors are. So if we saw p of 3 equals 0, that's telling us there's a remainder of 0 for the original polynomial. But if we sub 3 in for all the x's, what was the original binomial? Just like here, we had x minus 4 was our original binomial. We had a value of 4. Good. So if our value is 3, we would have x minus 3 as our binomial. So another way to think about it is they're saying x equals 3. So if you rearranged it to set it equal to 0, you would have to subtract the 3 over. Okay, again they're saying that negative 2/3 is a 0, so the original binomial, in this case, would be positive 3x plus 2. And if you're ever concerned about how you got that, just set x equal to the 0 and solve. You have to multiply by 3 on both sides. And then you have to move the 2 over, set it equal to 0. Okay? So if you ever have a fraction and you're unsure, just set x equal to it and set the equation equal to 0. Okay, the next one we have two polynomial statements equal to 0. They're saying p of 5 equals 0 and p of negative 2 equals 0. So that means that there's two factors, and we know that as well because they're saying determine a second degree factor of the polynomial p of x. So here we had single polynomials, or 1 degree polynomials. If we have two factors, x times x gives us second degree. So if we just saw p of 5 equals 0, what would you say the degree, or the binomial would be? X minus 5, good. And if we saw p of negative 2 equals 0? X plus 2. Okay, so then our polynomial p of x will equal x minus 5 times x plus 2. And we know it's degree 2 because x times x is x squared. Alright, the next question, they're giving us an option A and an option B, and we have to decide, is x plus 2 a factor of that polynomial, or is 2x minus 1 a factor? So, what do you guys think? Do you want to use synthetic division and go through the whole process to see if your remainder is 0? What's the more efficient way? Factor theorem or remainder theorem is pretty much the same thing. Okay, so let's just sub in p at negative 2 into the polynomial and see if we get 0. So we have 4 times negative 2 cubed minus 16 times negative 2 squared minus negative 2 plus 4. So evaluate that, and when you're done that, you can go into the next one as well and evaluate p at a half. So you're just subbing in the value into x. Okay, did anyone solve for the first one?
Yeah.
And what did you get?
90.
90? Negative 90.
Negative.
Negative 90? Okay. So, because this p of negative 2 is not equal 0, x plus 2 is not a factor. And what did we get for p and a half? 0. So because p of a half equals 0, we can say that 2x minus 1 is a factor. And the biggest thing is just if the remainder is 0, the given divisor is a factor. So the next question is pretty much alluding to what we're doing in the next lesson. They're asking us to show that 1 is a root of the equation given, and then we have to find all the other roots. Do you guys remember the definition of a root or some other words that would describe a root?
Zero.
Yeah, it's your 0, it's your x-intercept, or you could say it's like your solution. Okay, so we have to prove that 1 is a root. In other words, we have to prove that p of 1 equals 0. So prove that. That's basically what it's asking. Prove that p of 1 is equal to 0. And if that's the case, you will be proving that x minus 1 is a factor. Now, one thing that's different about this question is they're not just asking us to prove that this is a factor, they're also telling us to find the other roots. So not only will we use the factor theorem to prove this, but then we're going to use synthetic division to find the other factors, which will then discover the roots. Okay, so let's just sub in p at 1 first. Okay, p of 1. We got 1 cubed minus 9 times 1 squared plus 20 times 1 minus 12 equals 0. Does p of 1 equal 0? So we get negative 8 plus 20 gives me positive 12 minus 12, that's 0. So yes, we've just proved that it's a factor. And now that we know it's a factor, we can use synthetic division to find the other roots. So put a 1 on the side, and then we'll put the coefficients from the polynomial up top. So 1, negative 9, 20, negative 12. And we can start going through. Okay, bring down the 1, multiply 1 times 1, we get 1. Negative 9 plus 1 is negative 8. Negative 8 times 1 is negative 8. 20 minus 8 is 12. 12 times 1 is 12. Negative 12 plus 12 is 0. So if I were to answer this in the form the polynomial is equal to the divisor times the quotient plus the remainder, I would get the original polynomial is equal to, if the root was 1, what's my binomial from 1? X minus 1, good. And what's the quotient from here?
X squared minus
Good. And I don't need to write plus 0, but I'm just showing you that the remainder is 0. Hey, what can I do with this x squared minus 8x plus 12? Factor. And after I do that, I will end up with 3 binomials. So 2 numbers that multiply to 12 and add to negative 8, x minus 6, x minus 2. So from those factors, we have 3 roots. What does x equal? From the first factor. Second. Third. Good. So we have x equals 1, 6, and 2.